Good morning, my boys, fellow mathematicians, as Papa Flammy would say, and welcome back to another video. Today, we're going to be doing an integral of a very, very wiggly boy. That is the integral from 0 to infinity of the square root of x sine of x. And you can see it's wiggly because if you graph it, you'll have, this is positive square root of x, this is negative square root of x, and then our sine will start here and it'll bounce between them, getting ever so wigglier and wigglier off into infinity. I'll probably put the Desmos graph up here so you can see the full squiggliness of it. So, how would we go about solving this integral? To start, the integral from 0 to infinity, the square root of x sine x dx. To start, we're going to set we're going to do integration by parts. We're going to set u to be the square root of x, meaning that du equals 1 over 2 square root of x dx. Then our dv is going to be sine x dx. That means our v will be negative cos x, because it's the opposite of a derivative. And then let's add them and then minus that. So we're going to get this integral equals minus square root of x cos x plus, since we have a minus here, plus the integral of cos x over square root of 2x dx. And this seems almost harder than that integral, but we can do a u substitution there equals, and we'll set u equal to square root of x. So that means du equals 1 over 2 square root of x dx, or if we rearrange it, dx equals du times 2 square root of x. Okay. So that means we have the minus square root of x cos x, and all of this is 0 to infinity. The entire term. Square root of x cos x plus the integral from, if we plug this in for our dx, we'll get 2 square root x du. Putting the du before the cos is kind of risky. Cos x, but we don't want x, since notice we want it in terms of u. This means that u, if you square them both, u squared equals x. So it's going to be cos u squared all over 2 square root x. So then we're going to get the integral of cos u squared du minus square root x cos x, all from 0 to infinity. So this is a pretty hard integral right now. And if you don't know, it is defined, or it is called a the Fresnel integral. Let's go. It has a special symbol where it's c of x basically equals the integral from 0 to x of cosine t squared dt. So that is a Fresnel integral. So let me clean up the board and we can solve, since we can write this as Fresnel of, what is it, x, it is x, minus square root of x cos x, all from infinity, or 0 to infinity. Yeah! Let me clean up the board and rewrite it. Okay, my boys, let's evaluate this from 0 to infinity. So we're going to start with the infinite term, and we're going to get basically c, the Fresnel of infinity, minus, and this is where it gets a little controversial, the video, because if you have an infinite square root of infinity goes to infinity. However, the cosine of infinity, since it keeps oscillating back and forth, it's undefined. So I'm not sure why, but we can leave this out, infinity. Basically, we don't need it, and it still works out. So then we get the Fresnel integral of infinity minus, and let's get the 0 terms, c of 0 plus, since it's a minus minus, square root of 0 cos 0. And this cancels out. So then we just get equals the integral from 0 to infinity of cos x squared dx minus the integral from 0 to 0 of cos x squared dx. And since this is the integral from a to a, basically, we can cancel that out. And we've just proven that the integral from 0 to infinity of square root of x sine x dx equals the integral from 0 to infinity, 0 to infinity of cos x squared dx. And that'll help us a lot. Okay, now here comes the second part of the video. The part where it gets complex and a little controversial. And there's a move in there that a lot of you will hate. But it has to be done. And it works out, it gets the right answer. But I don't think anyone will like it. Okay. So, we want to find the integral from 0 to infinity of cos x squared dx. We're going to use two facts, two well-known facts. The first one is that e to the ix equals cos x plus I sine x. And that's pretty well known. It's Euler's identity. And I'll do a video on it in the future, basically proving it. And then the other fact we're going to use is the integral from negative infinity to infinity of e to the minus x squared dx equals the square root of pi. And that's also well known, and I might do a video on that in the future, I'm not sure. So first, let's put in, since we want x squared here, it looks like this, cos x. Let's put in an x squared into this identity. So we get e to the I x squared equals cos x squared plus I sine x squared. And then we want to integrate everything from 0 to infinity, right? So we're going to integrate everything in this.
0 to infinity, e to the I x squared equals the integral from 0 to infinity. Cosine x squared, here's our function that we want, there's the goal, equals the integral from 0 to infinity of I, we can take the I out, sine x squared.
And these all have dx's, I just didn't want to write them. So, first, this looks rather familiar to this, but it's 0 to infinity instead of negative infinity to infinity. So let's see, if we have an even function, we can cut the domain in half and it'll basically be cut in half, right? So is e to the minus x squared a negative, an even function? Well, if you plug in, let's see, what is it? Even function is if f of minus x equals f of x. So e to the minus x squared equals e to the minus x squared. Notice, because if you square it, it'll turn positive, and then it's negative again, so it's the same. Okay. I didn't mean to erase that.
Bruh.
Since it is an even function, if we divide the domain in half, the answer will be divided in half. So if we get the integral from 0 to infinity, e to the minus x squared, we will just get square root of pi over 2. Okay. Now, let me clean this up. And now we want to just evaluate this boy, because it seems the easiest. Alright, so we want to get this in the form of e to the minus x squared. And how can we do that? This is the illegal move that a lot of people will not like. But if it works, it works. We're going to set u equal to the square root of I x. So du will equal the square root of I dx. Can you do that? I don't care. So that means dx, du turns to the square root of I dx. We can just take that out of the integral. Square root of I times the integral from 0 to infinity, e to the I square root I u squared du. And then the square root of I squared, this equals the square root of I times the integral from 0 to infinity, e to the I times I times I is just -1, e to the minus u squared du. Yeah! Alright, and we know that this equals the square root of I times, we already proved it before, the square root of pi over 2. So now we have this whole thing, this right here, equals the square root of I times the square root of pi over 2. Now, what is the square root of I? Square root of I equals plus or minus, what is it? 1 over square root 2 times 1 plus I. And we can prove that if we square both sides, square both sides, so I equals, square this, 1 over 2, times, let's FOIL this, 1 squared is 1, plus 2I, and I squared is minus 1. So these will cancel out. I squared equals 1 over 2 times 2I, not I squared, just I equals I. So this is the square root of I. Now, we have that this integral right here, only the first one, equals square root of I square root of pi over 2. And the square root of I, we're going to use the minus square root of I. So it equals pi over 2 times minus 1, no, we're going to use the positive. Minus 1 times 1 over square root of 2 times 1 plus I. So if we get this all out, we'll get the square root of 2 pi over 2 square root 2, 1 plus
pi over 2 square root 2 I.
And if we put this into the square root, that'll be 4 times 2, which is the square root of pi over 8 plus I, the square root of pi over 8. Now that is the answer to this one. But notice that since this has an I, we can group it with the sine squared. And that this has no I, this is the real term, this is the answer to the cos x squared dx.
So,
This just equals the square root of pi over 8. Or, in other words, our original integral, our original wiggly boy, the integral from 0 to infinity, square root x sine x dx equals the square root of pi over 8. Isn't that just so nice? Beautiful. It's wonderful. And that, my boys, is a good place to stop.